Hi guys, Buildzoid here, and so it is very early in the morning right now, and I've been up all night, so I'm on full vampire hours at this point. Yeah, so I was thinking about my plans for B550, and sort of decided, hey, let's check out some boards, and then I noticed like ASRock's motherboard lineup is all on their website now. It's complete. Like some of the other vendors, they only have like a couple boards, and it's like this is not finished because there's a bunch of like you have the high end boards, but they didn't list the cheaper boards. So yeah, I don't really see a point of going through the lineups if they're incomplete because that means like then I'll be doing two videos, and it's just like that's a waste. See, unlike like where most YouTubers would go like, "Oh, I'll do one video that's like 30 minutes long about four motherboards and then I'll do another video that's 30 minutes long about the next four motherboards once they get, added to the website." Here with me, it's like, "No, we're going to make one very long video with all of the boards or no video. I'm nothing in between." So, yeah, anyway, but I've clicked on a couple of these already, and basically I was like, whoa, this isn't terrible. So this looks like it's going to be ASRock's redemption arc because I think their Z490 motherboard lineup is pretty much like it's about as bad as it gets in my opinion for Z490. So yeah, but the some like I've already like one of the cheaper B550s actually had me impressed. So, or what I assume is going to be cheaper. I just don't expect it to be super cheap because there are still some like high end components on there. Or well, not high end components, but like they're not not the componentry you find when your motherboard is very cost optimized. Um, yeah, I was relatively impressed by it. So this is probably going to be ASRock's redemption arc um, for motherboards because Z490 was a massive disappointment. So let's see. Starting off with the B550 Taichi, I also don't have any prices for any of these boards, so yeah, this should be interesting. So 16 power phase design, sure. I mean, like the thing with B550 also is like so B550 is really awkward as a chipset because it's like kind like it's trying to like it's meant to replace both X470 and B450 at the same time. Um, and yeah, so like the some of the boards have some really weird stuff going on with their like PCIe slot assignments and that kind of thing. So definitely if you're considering motherboards, I would strongly recommend that you go to the support portion and then download the user manual to figure out how all of the PCIe slots are wired because the user manuals should tell you. Anyway, so we're back to the overview. So yeah, I'm not seeing like this looks like this is the same or a similar VRM to what you'd get on like the X570 Taichi. Maybe it might actually be better. Not that I really care. That's a kind of low max memory speed, but maybe like the thing is like they might actually be real. So at the same time, that's not an actual XMP. So it's like, what the hell is that? Like if it was 4800 plus, it's like okay, so a 4800 XMP, and then anything you can do over that works. But 4733 is like this is not really a thing. Like the thing is, at the same time, it's Ryzen. Do you actually care if the motherboard is capable of supporting speeds higher than like 3800? No, you don't, because going over 3800 torpedoes performance by putting because you put yourself in 2-to-1 latency. I mean, 2-to-1. You put yourself in 2-to-1 Infinity Fabric to Memclock, and then, or no, it's Memclock to Infinity Fabric because your Memclock runs at twice Infinity Fabric speed. You get a massive latency penalty, and you're screwed. Um, Actually, it's not even the 2-to-1 mode so much. Like, the big problem is the fact that your Infinity Fabric and memory controller clock are going to be out of sync. Because your memory controller is going to be like, if you're running, say, 4800 memory, then your memory controller clock is going to be 1200. And your Infinity Fabric, if you actually like if you run 1200 Infinity Fabric with 1200 memory controller clock, you won't have the the desync penalty. But 1200 Infinity Fabric is so incredibly slow that it's just slow because 1200 Infinity Fabric is slow. Um, so you're still screwed. Whereas and so you basically need to run like 1800 plus Infinity Fabric with your 1200 memory controller, and well, you're screwed because now you have the penalty for going from like there's a couple nanoseconds penalty for going from like going between different clock regions. Um, so yeah. Anyway, So the like high speed memory support for on B550 is mostly just for showing off high memory speeds. It's not actually useful in day-to-day usage. And if the board is advertising 4733, like there's a chance that the 4700G, the giant 8-core APU, like that probably does higher Infinity Fabric clocks than the normal Ryzen CPUs because it doesn't have chiplets, so the Infinity Fabric never has to go off silicon, right? Because the main problem with the Infinity Fabric is it goes silicon to substrate back to silicon, and in theory, like I would assume the main limiting factor for the clock speed of the Infinity Fabric is the fact that it has to go through the substrate. Um, but for the 4700G, if that exists, I don't know. I've not bothered to ask. I'm not actually that interested. But if the 4700G is real and has, and it's an 8-core APU with no external, like the Infinity Fabric never leaving the silicon, then that might go, 2000 megahertz Infinity Fabric clock. And in that case, you need support for at least you'd want support for like DDR4 4000 or something. So, so for that CPU, the higher frequency support might actually be useful, but I still don't think it's going to be going, I still don't see any way it would need 4733. So anyway, that's some random considerations right there. So what do we see here? So there's a lot of phases. That's cool. I wonder if they're on the new Infineon controller for that, because there's been they could also be on intersil, and actually ASRock generally likes to use intersil parts, so it might still we'll see. We'll definitely see. Anyway, so we have a postcode power button, reset button, internal clear CMOS. Is there a rear I/O clear CMOS? Oh, there is. What the hell? That why don't we have this on Z490? Or yeah, see? This is what I like to see. There's no harm in having two clear CMOS buttons. There is harm if the only one is internal. Yeah, so also BIOS flashback functionality, Wi-Fi 6, a decent number of USB ports. I would have still preferred more, but this is not that bad, okay? It is 7 USB ports. I think it would be cool. There's more USB ports is always better in my opinion, but I can live with 7. 5, not so much. Anyway, what else is there? Two-phase memory VRM, and this is actually a real two-phase. There's a lot of ASRock boards that have the componentry for two phases, but they don't have the controller. But this one has the controller, because that chip up there, okay, well, you probably can't tell, but the chip right above the memory slots, right? That is actually, the single-phase controllers don't look like that. That is a multi-phase controller, because otherwise you would have a much simpler package for the chip. Anyway, so let's scroll through and see what else there is. So it's on Wi-Fi 6, of course, 2.5 gig Intel. That is really random. It's there's a bunch of, Intel 2.5 gigs, so that's interesting. Because there's a bunch of Z490 boards which are on Realtek. So anyway, I wonder how Intel feels about ASRock making nicer AMD boards than Intel boards. Using Intel's LAN chips. They probably don't care. They're still selling LAN chips, right? It does, Intel ultimately doesn't care who you sell, why they're selling. Intel, as long as they sell you. Oh, it's also Intel Wi-Fi. Yeah, so they're cool with selling more networking stuff. But still, it's yeah. Anyway, so 50 amp DR MOS. Okay. Well, the thing is, if this is 16 phases of 50 amp power stages, that is plenty of power. Then we've got 2 8-pins, which is completely unnecessary. Even with a 3950X, you are not going to max out a single 8-pin on ambient cooling because the chips just run way too damn hot. 15 micron gold contacts absolutely everywhere. This is this might sound like a silly gimmick, but let's say you're running a lot of, if you're going through a lot of GPUs or a lot of memory sticks, this is actually useful. Having, a thicker gold layer means that it wears, it takes longer to wear down the pins. So if you're binning memory, this is kind of useful. So there's, I don't think that's a bad addition to a motherboard. It sounds kind of gimmicky, but, This is one of the things I actually kind of like. Yeah, this is cool. Like there's no harm in having that. Also, it might slightly improve contact, even without like wearing down initially, just because gold is kind of soft. So yeah, what else do we have? 12K caps, which that doesn't matter. Like on the high-end boards, everybody uses 10K, and then ASRock has to one-up them, so they use 12K, which is like, okay, fine. No, I don't have a problem. Like, there's no harm in that, but I don't really see that as like a beneficial, significantly beneficial feature. PCIe slots, yep, with the steel reinforcement. Nothing really bad here. Metal backplate. I'm a big fan of backplates. Backplates are cool. They just make motherboards so much more rigid and hard. Like you're not like I just like backplates. I'm not gonna get into all of the reasoning why I like motherboard backplates. So yeah, so far I like it. What else do we have? We have the page not loading. That's what we have. PCIe 4.0 for everyone with B550. Fun fact, the chipset doesn't do B550, the chipset doesn't do PCIe 4.0. So the only 4.0 you get is from the CPU. Like the thing is, so Hyper... Okay, so they obviously have some chipset-based PCI, like chipset-based M.2 slots. So there are some boards, like I think Gigabyte's board, Gigabyte decided that they're going to have 3 PCIe 4.0 NVMe, like M.2 SSD slots. And the way they're doing that is they're taking the PCIe lanes from the CPU, which you only have 16 of, right? And they're basically switching them into the M.2s, which I think is kind of like... Well, if you really want fast M.2s, then I guess that makes sense. But I feel like slowing down your GPU just so your SSDs can be faster. Like if you have a 2080 Ti on that board, that's actually a really bad idea because you'll be running your 2080 Ti at X8 3.0 and well, 2080 Ti's kind of max that out, so it's not exactly ideal. Anyway, that's actually a very substantial backplate, so I do like that. It's not a completely full cover, but like they are using it also for heat sinking the VRM. Not that, that they should need that with how many phases this supposedly has. I'd love to know if this is interesting. Actually, 50s, considering they mentioned 50 amp parts, these have to be intercell, because, well, no, International Rectifier makes 50 amp parts too, but I don't know why you'd use them. And this is ASRock. Like, ASRock really likes intercell parts. Like, I think their entire TRX 40 lineup is intercell. Their X570 lineup, I think, is all intercell for the high end. So I'm going to assume this is just more intercell, which is fine. There's nothing wrong with intercell voltage controllers. Like some of the best, like one of the best Z390 motherboards in terms of voltage regulation is an intercell VRM design. So yeah, I don't really have like a specific brand preference for, like Intercell, International Rectifier, or whatever. There are some brands that I would avoid, but that's more like when you're looking at discrete MOSFETs, and there it's like, don't use Nyko Semiconductor for your main power rails. Nyko Semiconductor is okay for like memory power and memory controller power, and absolutely nothing more substantial than that. Anyway, so 2.5 gig Intel. Yeah, so at this point, like, there's not really much else down here. So I don't care. No point scrolling through the whole thing, is there? Yeah, I don't see much point scrolling down through it. Yeah, we just have the usual sort of marketing stuff. Which, like, the high-density glass fiber PCB, that's just basically a requirement for getting reliable PCIe 4.0 speeds. Combo caps, which mix of 820 and 100 microfarad capacitors. Yeah, that's a thing. So, anything IO armor, new design protective cover for all crucial parts near so they won't be easily damaged by stat. Okay, okay, this is actually silly. I'm not sure this is the. Um. Yeah, no, that doesn't make any sense to me. 2-ounce copper, that's standard. Matte black PCB, it's just a black PCB, come on. Premium memory alloy choke. The thing about memory is it's not that hard to power. Like, it just doesn't pull enough current to need, like, super, special power delivery. 50 amp continuous. like there should be an asterisk next to that, because 50 amp continuous on a power stage is like even if you have a say a 90% efficient power stage, right? At 50 amps output, so 50 amp, and you normally, like, if you're at the limit of what the power stage can do, you won't be looking at 90% efficiency. But 50 amps going through a power stage at 90% efficiency, 1 volt output voltage, you're going to be looking at like 5 watts of heat coming off of the component. If you have like, I don't know, 10 of them next to each other, that's you know, if you have 10 of them under this kind of loading, then that's 50 watts of heat. Uh, you kind of need a hell of a lot of cooling in that scenario. Anyway, so yeah, overall, I rather like this. The main concern, of course, is how much is this going to cost? And I think this board is probably approaching $300, which is really... Actually, no, they can't have this going near $300. That's complete... Like, if this is approaching $300, then it's competing against the X570 Taichi, which is just completely stupid. Like, just think about it, right? Like, the X570 Taichi is a $300 board. You can't have a B550 that's also $300. That just doesn't make any... So probably 250... Like, I hope they're aiming for, like, 250 with this or something. But yeah, like, there's nothing... Like, I don't see anything that I don't really, like... I'm not seeing anything I initially dislike about this board. It's just, like the price really is... The price will decide ultimately if this is actually worth buying or not. But as a board, it's nice. It's just how much is it going to cost? So moving on, B550 Extreme 4. I have to admit, I'm a sucker for this color scheme. Like, I really like this color scheme. Like, the pale metallic blue. And I don't like the color blue very much, but pale metallic blue, like, that is a good... That's a good shade of blue. Two-phase memory power, so that's fun. How much? 14-phase VRM, so probably a 12 plus 2. That is an interesting capacitor arrangement up there. Like this right here. Like, it probably doesn't affect anything. It's just kind of like weird not seeing them all in a straight line. Anyway. Kind of feel like their V-Core VRM is really far away from the socket. Which, that's not necessarily ideal. But, yeah. Oh, cool. Postcode, power button, reset. Man, this is really nice. How's the rear I/O on this? Also not completely terrible. What? Like, this is a nice board. I like this. Like, I'm assuming this is on 50 amp power stages, right? I have the 8-pin and the 4-pin. Not that you're going to need the 4-pin, but, you know, it doesn't hurt anything by existing. Dragon. Oh, yeah, right. So this is the Realtek 2.5 gig. But, yeah, who knows? Well, the thing is, I've not tested any of... Like, I can't test 2.5 gig LAN for reliability. Like, I straight up don't have 2.5 gig networking, so... Yeah. Anyway, what do we have down here? 50 amps. Okay, wait. I'm just going to check that that's actually... Because I think they also spec it in here. 60... Yeah, 50 amp power stages. I like it. Like, I'm very surprised, but I really like this. I do wonder... I'm going to guess this is like 220. This looks like a $200-ish board. If it's like significantly more than that, then then I have problems with it. But if it's around like 220, maybe... Yeah, 220, I think this would be a nice board. Still kind of close to X570s. Like, that would basically put this up against the MSI X570 Tomahawk. But that doesn't have a postcode or a power button or a reset button. And I do really like having a postcode. Though postcodes on AM4 don't help you that much. It's not like most of the time on AM4, if you're doing memory overclocking, it either works or it doesn't work. It's not that fiddly. Like, it'll either post or it won't post at all. I've not really run into it getting like stuck on specific postcodes that tell you, hey, you should do this or you should do that. It's mostly like, nope, you're screwed. So, yeah. But still, like, that is I like that. So let's see what other options we have. Now, normally the B550, the Extreme 4 and the Steel Legend are about the same price. That's probably because they're basically the same board with different colors, and this one has the yeah, that on the PCB. Postcode, oh, they removed the buttons, but you know, that's actually a really minor loss. Like the postcode is, out of all the overclocking features, the postcode is, in my opinion, by far the most important. So, and so, like, I'd assume this board's going to be like $10-20 cheaper, unless they added something to the rear IO that's missing here. This one doesn't have Wi-Fi, and this one, yeah, also doesn't have Wi-Fi. Wait a minute. Extra display outputs. That is why I am confused, but like, why aren't they the same? But same memory power, two-phase. I'm assuming, yeah, 14, it's the same board. I'm surprised they didn't, like, the funny thing is, like, in theory, it should be really easy to just cut down high phase counts by just, like, leaving out 1 or 2 power stages. Like, use the same PCB and just don't populate 2 of the phases. And, like, I honestly wouldn't, like, if they did that and shaved off a little bit more on the cost, I still wouldn't have a problem with that. Depending on how the VRM's laid out. But this should have, like, 2 phases of VCore under this heatsink, and then the remaining 10 phases of VCore on this heatsink. So if you just, like, strategically removed 2 power stages to reduce the thermal density, not like, visually it would look horrendous because you just have this random missing inductor in the row, but you could cut down the thermal density a bit, or more like you wouldn't cut down the thermal density, but you would end up with less phases, but you wouldn't have as high a thermal, like you'd have like a lower thermal density 8-phase setup instead of like a higher thermal density for 8-phase setup. Still less phases overall, so the heat output would be the same. It's just like how it would be spread into the heatsink would be a bit different. Actually, wait a minute. Does this have... No. PCIe slot-wise, they're also about the same. I'm not seeing any PCIe 4.0 switches. Also, both of them only support Crossfire. Wait, did the Taichi do SLI? Because that's always interesting. Also only Crossfire. Does it literally only do Crossfire? Because that, like, if a board does or doesn't do Crossfire, gives you a pretty good idea of how the chips, like the PCIe slots, are allocated. Because you need X8 for your second, like if you're doing NVIDIA SLI, you need a second X8 slot. So 3x PCIe slots. There is an X8. Or dual... One, two, three, yeah. I guess they just decided not to buy an SLI license for the board then. Which I guess makes sense, because, you know, cheaper board if you don't pay for an SLI license. Anyway, so this actually looks like... This looks like a better option than the Extreme 4, even though visually I do like the look of the Extreme 4 a lot more, but yeah, this is a better option because you still get to keep the postcode, same VRM, same rear IO. Yeah, so Steel Legend B550 actually looks really quite solid. And it's still on the same power stages, isn't it? Yep, exact same power stages. So, it's a fun board. What else do we have? B550 Pro4. And no, let's go with this. This looks more high-end. Let's keep the disappointment for the end of the video. So, still the same... Are they just, like, using the same PCB over and over and over and over again? Because that's what it looks like right now. Like, that is the same rear IO. And let me guess, same PCIe slot layout. Yup. Buttons are in the same spot, postcode again. There's that big blank spot, 2-phase memory power. I really like the 2-phase memory power just seems unnecessary to me. Like, single-phase memory power would be fine. But the thing is, I'm pretty sure, like... Yeah, they could have, like, taken this memory VRM, dropped one of the extra inductors, in my opinion, and put that on here, and I wouldn't have a problem with that. So, actually, that's it's missing on this one, too. Also on this one. Yeah, there's like unpopulated connectors down there. So I was like, oh, maybe one of them has those. Nope, none of them have them. They're just kind of there. So I guess that was like one of those features where it was like, oh, we might add this, and then they decided, actually, you know what? No, we're not gonna add that. Same VRM. This time we have a heat pipe in the heatsink. Wait, does this have VRM fans? This better not have VRM fans. I'd be very disappointed if this came with VRM fans. I'm not seeing any mention of VRM fans, so that's good. Because this shouldn't have VRM fans. Doesn't need them. They shouldn't be there. Okay, so we have like... The thing is, like, wait, so what's the point of this, though? Like, why do they have so many of these... Wait, where are they getting a 3.0x16? Is that coming off of the chipset? Because if that's coming off of the chipset, like, that's... No, like, that's an X4. You can see it from the coupling capacitors for the PCIe there. Right, those little caps right there? You can tell, like, there's only 4 lanes going into that. Well, the rear I/O looks okay, and I'm not really seeing anything like it's just another Extreme 4 in a different color scheme, which like yeah, so that's interesting. So I wonder how they're gonna price these, because if they're all the same price, then that's gonna be kind of, well, the Steel Legend should be a little bit cheaper. But I can't imagine it being significantly cheaper, because it, like, to me, it just looks like they removed the power and reset buttons, and that's like, that's not a big change. So, yeah, and they added the, actually, wait a minute, they added the DisplayPort, so they might end up costing the same. Man, that is so, like, that is weird. Okay, so we have three basically of the same board in different paint. So now let's take a look at what I'm assuming is the beginning of the disappointments. The B5 is that. Oh no, wait, B550M Steel Legend. There. We're gonna delay the disappointment stage of this video for as long as possible. So B550M Steel Legend. Let's check out the rear I/O. Yeah, see, this is rather nice. Oh, clear CMOS in the rear I/O as well. This is actually really cool. Does this have a postcode? If this has a postcode, that would be amazing. No. Ran out of space, apparently. Which, yeah, I mean, it makes sense. It's an MATX board. Decent PCIe slot spacing. Like, you could run a GPU and then, like, a more substantial card down there. The one thing I'm wondering about is, like, in my experience with AMD chipsets, like, there are compatibility issues with certain PCIe cards and running them off of the chipset. Like, some of them you just have to run them off of the CPU lanes, which gets kind of awkward. Because obviously you ideally want your CPU lanes for the GPU, but... Yeah, like if you're just gonna add like if you wanted to add like an SSD to the last PCIe slot, that should be fine. Or networking should also be fine. Like my problem with it was a capture card, and maybe other capture cards don't have those compatibility issues. But yeah, like I'm always like the thing is, it's not really like B550 isn't really meant to be like a workstation-ish platform, so. Yeah, not really that much of a concern. And I guess most people probably won't even use that last PCIe slot. So what else do we have? 10 power phase VRM, okay. I'm not really a fan of those heat sinks, but then again, it's really hard to tell how far this one extends. Also, I'm not a fan of the phase layout, because they have all 10 vCore phases jammed under that one heatsink, and then they have the 2 SoC phases up top. Which, like, it makes sense from a layout perspective where, like, you know, space available on the board. But thermally, you're going to need a hell of a heatsink for your 10-phase vCore. Actually, 8-phase vCore. So, yeah, because that's going to get potentially... Yeah, that's going to potentially get kind of hot if you have all 8 of your phases right next to each other. But again, if you're not running a 3950X, that shouldn't really... Like, if you're on an 8-core, you're going to be just fine. It's only like with a overclocked 3950X that would become a concern. And, you know, like how many people are going to stick a 3950X in? Well, actually, if you're doing like a B550 build and you want to use a 3950X in an MATX case, this is probably one of the best motherboards to go for. So actually, that is a valid concern. Is like, just get your own fan for it, right? Just get a $5 fan, fix the thermals. Um, no BIOS flashback, which yeah, so no BIOS flashback on this. I think BIOS flashback being on like so many motherboards is just like a Gigabyte MSI thing. Like Gigabyte actually does it more than MSI does it. Like Gigabyte basically has BIOS flashback absolutely everywhere. Um, and then MSI has like a few boards with BIOS flashback, and then ASRock and Asus don't do it anywhere near as much. And ultimately, it's not really like it's a feature that only becomes useful if you've either screwed up a BIOS flash or if you're buying a motherboard and a CPU that isn't already supported by that motherboard, which like I would generally not like, you know, like maybe I don't know. Like the thing is with B450 and Ryzen 3000, the situation was really awkward because AMD didn't launch a low-cost chipset option because they screwed up B550, which some people would say AS Media screwed up B550, but in my opinion, AMD should have had a backup plan. Like you can't just go like, yeah, we're gonna have B550 made by a third party, and when that third party ultimately goes like, yeah, we can't meet your specifications, we're just gonna go like, okay, we're just gonna delay the chipset for a year, which is basically what happened with B550, and it still doesn't support PCIe 4.0. Um, but yeah, so because if B550 had launched, you know, with X570, then it's like you wouldn't have had people like having BIOS flashback on B450 boards wouldn't be a useful feature because you wouldn't be buying B450 boards for 3000 series CPUs unless you were extremely desperate. In which case, you know, like, uh, well, still don't do that, in my opinion. Just buy a cheap B550 in that case instead. Like, if the B550s had existed. But, yeah, anyway, so I rather like this. So this is on the single phase memory VRM. Like I don't get why they're like keeping the two-phase memory power on so many boards. Like it really doesn't make like DDR4 power delivery in my experience makes so little difference to overclocking that it's like one of the first things I would axe as a cost saving thing is two-phase memory power. I would just go straight to single phase. I wouldn't even bother with the like ASRock here has 4 MOSFETs, 2 inductors. I'm not sure what the specs on those inductors are, but if there was an option to get a single inductor that does the appropriate amount of current and costs less, I would go for a single inductor, and I would also drop one of the high side MOSFETs. So just 3 MOSFETs instead of 4, unless they're also, well, no, 3 MOSFETs instead of 4. You could even go down as low as just 2 MOSFETs, just high side and low side, but kind of depends on the motherboard in that. Well, no, that like still should like depends on the MOSFETs you're using, and even then it should still be fine. Anyway, so yeah, I rather like this. For like 8 cores, this should be a solid MATX motherboard. For 16 cores, depends on what you're doing with your 16 core. Um, and also, it really like it's hard to tell how much of this rear I/O cover is plastic and how much of it is actual heatsink, which is kind of annoying. But yeah, this looks like a surprisingly solid MATX motherboard option. Anyway, let's try scrolling through. Yeah, so you've got your 8+4 pin, not that you're going to max out the 8 pin in the first place. Realtek LAN. Yeah, I rather like this. This is actually not terrible. I mean, you know, it's just kind of like, it's just a cut down version of the ATX boards. Like, what I'm surprised about with X570 is like, well, I'm not really surprised. Like, the thing is with, I mean, not X570, B550. Like, the thing is, like, in theory, what would be great for thermals is, and you couldn't do it on a board like this, but if you have a board like, say, the Extreme 4, where you have a lot of space above the CPU socket, what could make a lot of sense is instead of having the VRM laid out where you have like 10 phases over here and then like they have 10 phases on the IO side and then 2 phases of V-core in the top heatsink and then, well, So Asus does this on their X570 boards. Well, they'll have two SoC phases just sort of sitting in the middle of their V-Core VRM, which I think is a really cool idea because the SoC VRM doesn't put out a lot of power, like doesn't need to push a lot of current, so it doesn't really get that hot, and it's significant, like it spreads the heat out over, like it reduces the heat load on the heatsink. So essentially the whole VRM ends up running slightly cooler because you've reassigned where the hot spots are to be more far away from each other. But yeah, like with a setup like this, it's like, why wouldn't you put 8 phases on this heatsink down here, and then the other 6 phases on the top one? Right? Like that would probably be more effective for cooling. And actually, you could have like 4, like you could have a SoC V-Core V-Core, or maybe like V-Core SoC V-Core. Though then you have to get fancy with the power planes, and that might get kind of awkward as well. So yeah, I guess. And there's a bunch of considerations for that, but like Asus does it, so evidently it's doable. It's just like I'm not sure how complicated it is to actually implement in practice. Anyway, where were we? So yeah, B550M Steel Legend looks okay. Moving on. We've done that, so I guess let's finally take a look at the Pro4. So let's start with the rear I/O. Yeah, see, this right here is what disappointment looks like. Look, it's the rear I/O of your average ASRock Z490 motherboard. What do you mean there's not enough USB ports? Anyway, so the VRM on this, 8-phase power design. Oh, uh-oh. And this is definitely not on power stages, is it? Yeah, it is not on power stages. So this is going to run pretty hot, though they do have the very big heatsink. Like having a heatsink like this, it actually works quite well. Like converting your rear I/O cover into a heatsink, like it's a lot of surface area. It doesn't look like it's a lot of surface area, but it is a lot of surface area. It's like it's a massive, heatsink fin. So that actually works quite well as a heatsink. I wonder if they specify the PCB layer count anywhere. Because I'm going to assume it is, like 4533 here. And then, wait, the APUs apparently have better memory support. Interesting. Actually, wait, if I go to the, what else am I, wait. Oh, no, wait. Oh, they've not released like the compatibility lists. I guess those they're not allowed to release those just yet. What did I want to check in here? There was something I was like, oh, I was thinking like, let's see if the 4700G would be in like the CPU support list. Because that would basically just be the easy way to confirm that it exists. Though I think at this point it's pretty much, well, I think it makes sense for that CPU to exist. And also, like, what other APUs would you, like, what other APUs would this be referring to, right? So, yeah, high density glass fabric, okay, but no layer count, okay. It has to be a lower layer count. Like, I don't think swapping memory topology, like swapping the memory VRM over from a 2-phase to a single phase cost them, 200 megahertz of memory clock. Like that just doesn't sound possible. No, specs. Oh wait, they have 4533 everywhere for Matisse. The heck? Am I blind? Did I not notice that? No, here they have 4733 again. So this is on a different memory topology as well. Trying to see if... Okay, no, they don't have the little... Well, if there is a layer count indicator, I don't know where it is. Also, it looks like they have some troubleshooting LEDs down there, which is a really awkward location for troubleshooting LEDs. But at least they exist, which is always nice. So, yeah. Anyway, so I actually rather like the Steel Legend boards, and so the higher end B550s from ASRock actually look quite decent. Anyway, let's go back to this. So I'm going to assume this is a 4-layer. The M-ATX board might also be a 4-layer, and I'm assuming that just because of the memory speeds that they're advertising. Realtek 1 gig. Okay, no, they're not mentioning like there's some boards where ASRock mentions like a special name they have for their memory topology, and I noticed it on some Z490 boards. And yeah, I'm not seeing that here, so that's kind of sucks. But I'm gonna assume this is a 4-layer PCB. And yeah, I mean, as far as this board goes, like if this is like I would guess that this is gonna be approaching $100 in terms of price. And also, like they mentioned post status checker. Where are they? Like that, I'm assuming there's LEDs somewhere. Right? Like, but where? Oh, I guess they're above the dim slot? No, that doesn't look like it. Oh, come on. Oh, it doesn't get any bigger. Damn it. So where are the post LEDs? Like, they're somewhere. Oh, I guess they're down here. Okay. Yeah, that looks like where they are. Anyway, so moving on. What should we do next? Let's take a look at the ITX board. What did they do with this one? Oh, this is actually relatively high-end. Phantom Gaming, yeah. This is supposed to be like a nice ITX. 8-phase. Ooh, I wonder if this is on 90s. It is on 90s. So, fun fact about the 90 amp smart power stages, they're not significantly better than the 70 amp smart power stages. They are really, like, they're really good, and they are ever so slightly better, but it's not like a huge, massive upgrade. But yeah, so it is on the 90s, so that's exciting. Also, interesting that they managed to squeeze right angle SATA ports, because normally on ITX boards you don't see those. What's the rear I/O like? ITX grade. But yeah, it's an ITX board. If like here I can understand only having 5 USB ports. There legitimately are space constraints. Then we can't see the output filter, like we can't see any of the, well, this has to be all SMD like aluminum polymer capacitors on the back of the board for the output filtering for the VCore VRM, because on the front we only have these large multi-layer ceramics. Also, these large multi-layer ceramics in the 1206 package, at least according to their manufacturer specifications, the like frequency response curve for them is not like it basically looks like a aluminum polymer in a like of an even larger capacitance. So yeah, these aren't actually that great. Like the main benefit to these is that if you are like they're great if you don't have enough space. They're not so great outside of that application. So yeah, they're not like somehow massive. Like they're not like because they're so big for multi-layer ceramics. They're not actually that impressive in terms of their ESR and ESL performance. So this is going to be like 6-phase V-core, 2-phase SoC. Actually, I wonder if they did 7+1. Because if the 7+1 would, in my opinion, make... Like, it would make a lot of sense. Because if you have a 90 amp smart power stage for your... At the same time, this probably... 4700G... Like, if you're overclocking the iGPU of a AMD CPU, the iGPU can get actually quite power hungry. If you have fast memory... and you're not like, and you're actually like, if you can feed the iGPU, it can pull a lot of power, because the main thing that limits the power, both the performance and the power consumption of an iGPU and an APU, is the fact that it's constantly waiting for memory access. But if you have fast RAM, yeah, it can really like it can open up in terms of both performance and power consumption. So probably like this is going to be a 6+2 because running it as a 8 like 7+1 like it would be cool for something like a 16 core 3950X, but it wouldn't be cool as soon as you grabbed an APU. I am surprised they didn't cram a fan into the VRM heatsink. Like there's no vent holes in it. That actually I'm not really a fan of that VRM heatsink in general. Like that is very I get that they didn't have a lot of space, but that is very much that looks like an L-shaped plate. At the same time, 90 amps more power stages, so it should be okay. Depends on what you're doing with the board, I guess. And then there's always the option just point a fan at it, right? If you point a fan at it, it's not going to be a problem anymore. I wonder how the memory overclocking is going to be. Only 4700. So it doesn't look like this is because ITX boards will sometimes be just crazy good at memory overclocking because of not having 4 DIMM slots. But it looks like ASRock. It looks like ASRock isn't actually interested in doing that with this board. But still, interesting board. Like this isn't a bad option. 8-layer PCB. Okay. That doesn't surprise me. It's an ITX board. Like ITX board get extra layers just because of the space constraints. So it's not even like a 6-layer ATX can often will potentially be better than like an 8-layer ITX in terms of say memory overclocking just because on the ITX board you're really strapped for space to connect things with. Whereas on the ATX board, if you're doing an Apex style 2DIMM ATX motherboard, you don't need that many layers because there's not that many trace. Like you can just go around the memory. You don't need to go over it. So then you don't need so many layers. Intel 2.5 gig. Yeah, I rather like this. Like I'm not sure that this is the best ITX motherboard, but depending, if this is like cheaper than some of the other ITX options, this is definitely a solid board. If it's the same as some of the other boards, then it depends on the feature set. But yeah, I'm not seeing anything immediately that's like, oh, I don't like this. This looks awful. Like the heatsink looks a bit skinny, right? Like it looks a bit thin, and like it's not actually gonna do like also like it's gonna be like the Wi-Fi card is blocking a lot of like airflow potentially for the VRM heatsink. So yeah, that is my main concern. But if you're like, it depends on what CPU you're running and how you're running that CPU. Um, so yeah. Anyway, moving on. Let's do the other ITX. Right? Like there's no plan here. Oh, this one doesn't have a full page yet. We don't need the full page. This looks like the same VRM almost. Oh no, they've shifted it up. And 50 amp power stages. So this is like for wait, how many phases is this? Doesn't mention. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's a 6+2. I would not put a 16 core on this. You should still be fine with APUs though. That heatsink though is that heatsink is oh man. That is okay, so from the top it looked unimpressive, but from the side that looks straight up concerning. Um that can't like the funny thing is, looking at that, you might be like, oh, so it doesn't actually add any surface area at all. And that's not entirely true. This probably triples the surface area of the bare MOSFET. Like, as in, if you had no heatsink whatsoever, the MOSFET would have like 1/3 of this surface area. At the same time, uh, yeah, as far as like heatsink designs go, this does not look like an efficient use of space or material. Yeah, I am not a fan of that heatsink. Like the VRM under it, like if they had, actually, like basically, in my opinion, what they should have gone for is a heatsink that, like the thing is, like it would be ugly, I guess, is the main concern. I wonder if they have any boards with that style of heatsink on this. No, but they had them in the past. Wait, so I'm gonna go through ASRock's old boards. Because I know for a fact that they used to do heatsinks like this. So I'm going to find an example of a heatsink that I think would have been better. Oh man, they don't have any of the old chips? Actually, wait a minute. This might have it. Yeah, see? This. I, they should have gone for that style of heatsink, right? With actual surface area. And yeah, like this one is a little bit too thick for the space that they have on this board, but they could have cut it down to be slim enough to fit where those MOSFETs go. Um, and then they should have just had fins on that. Like I would have preferred if the fins were even taller, but like because this right here is basically a cube. It's basically a yeah, or not a cube. It's I don't know the word for that shape. That really sucks, but that's basically just a block. There's no surface area there. What's the rear I/O like? So this is like this is for running at stock. Actually, wait a minute. There's capacitors hiding under that. So that is less than a block. That's an L shape. Like if we could see from the top, that would be like an L shape. So it's not even gonna have any mass. It's just like, oh man, that is one like bad heatsink right there. That's probably the worst heatsink I've ever seen. Actually, no, that's not true. ASRock has had boards with even worse heatsinks in the past. But man, like this right here, that is like like for I can't believe that they've actually done that. Like that's like it's not anything. Anyway, rear IO. Okay, so ITX grade number of USB ports. The funny thing is, like with this pathetic little heatsink, they could have made that this USB port set right here. They could have made that 4 ports tall. And that would have, in my opinion, kind of like actually they could have made this 4.4 ports tall and still had a bigger heatsink. Because like the main issue is that heatsink is not only like flat, it's not even tall. Like yeah, that is like they should have just turned it into an IO cover. Like they should have just literally raised it until it could go over the USB ports, and that would have been a significant upgrade. And yeah, I'm aware that they have the 8-pin jammed into the between the ports, but you could just have a hole where the 8-pin has to go. Though that would actually get really awkward for when you want to unplug the 8-pin. You'd have to like uninstall the board. Actually, no, if you didn't have an IO shield, it wouldn't be a problem. But if you do have an IO shield, you'd have to like unmount the board from the case, pull the board out, then unplug the 8-pin, because otherwise you're not getting it out. Oh man. Yeah, ITX is just like a really like the form factor presents some unique design challenges is one way to put it. Unique design challenges indeed. So yeah, the thing is, if you're on like a quad core, like if you're on a weaker APUs, then this should be fine. And maybe even, I don't think I would want to run an 8-core on the, 6-core APU I'd be fine with. Like a 3600 Ryzen shouldn't really be a problem, but 8-core you might actually start having issues with this, plate right here. Yeah, so, but still, like the board itself, like the things on the PCB itself aren't that bad. It's just like that heatsink right there. You could actually, if you bought some thermal tape or thermal epoxy, you could probably glue on a bunch of like little memory heatsinks and improve the VRM thermals a bit. Like that would actually work because like that does work actually. Like obviously it's better if you have a heatsink made out of one block of metal, but taping heatsinks onto the existing very flat heatsink can actually work. So yeah, that is a potential option. Is just get thermal tape and add your own heatsinks on top of that, because this is probably going to be one of the cheapest B550 ITX boards out there. Like I'm gonna guess this isn't going to be that expensive because it doesn't look like it's supposed to be that expensive. In which case, it could be an interesting option. If you're willing to, because, well, how much do VRAM heatsinks cost? Because the thing is, I take that for granted because I just kind of have a bunch of them sitting around. So if I was buying this board, I would just glue on a bunch of heatsinks and, yeah, or tape on a bunch of heatsinks and probably get better thermals than it comes with out of the box. But you'd probably get them for like $5. So yeah, depending on what the price gap is between this board and something better, that might actually be a totally reasonable solution to the heatsink situation here. because yeah, that is not a heatsink. There's no debug LEDs, which makes sense. It's an ITX board, but I was kind of hoping they might have managed to squeeze those in. Also, they have to have an again, like all SMD capacitor output filter. I'd love to see the back of this board. Like that's not cheap. Like SMD polymer capacitors are quite expensive. So yeah, anyway, so this is an interesting motherboard from a sort of like, I wonder what you could do about the heatsink situation because it has one awful heatsink. But yeah, the actual VR, like the underlying VRM itself is not that bad. It's just like they ran out, like, well, it's a cost space thing with the heatsink right there. Um, and also an aesthetics thing. Like that heatsink is obviously not designed with just cooling in mind. Anyway, so moving on, let's go B550 Phantom Gaming 4. It's a Pro 4, but with worse cooling, isn't it? I should probably have them both head on. Come on, load, damn it. Yeah, it's the same PCB. Like, you can see it's the same PCB because that, what is it, VGA port? You can see the pinout for that VGA port, and it's just not populated. So, you can tell. And the VRM, yeah, 8 power phase, same VRM. They finished the page for this thing, as awful as it is. Would have preferred the page for the B5, this ITX board right here. That board is interesting just in terms of how awful it looks. Anyway, that heatsink is literally a joke. At least to me it is. Okay, we have post checker, cool. Yeah, I'm gonna assume, like, this is gonna be a 4-layer PCB as well. Yeah, discrete MOSFETs. I mean, like, depending on how cheap, like, because if you're running a 6-core, you really don't need that much power. And even the 8-core, like 3700Xs don't need that much power. So yeah, it wouldn't really be a concern for those kinds of CPUs to run something like this, but I don't know, like, depends on the price gap between this and this. How's the rear I/O? Pretty awful. Yeah. Actually, for me, this would actually be better because I have like no USB Type-C devices other than like my phone. So, yeah. Anyway, so that's the Gaming 4. And this also has the post checker. Yeah, it has the post status checker, so I don't know. Like, this depends on the price. I'm going to assume this is a sub $100 board, and for a sub $100 board, it could be worse. Like, at least I think this is the same VRM that they have on the X570 Pro4, and that's a 4-phase, not a 4-phase, 8-phase with actual doublers. So, yeah, like, this might not actually be that bad a VRM. It's just like there's no heatsink, essentially. And is this MATX or no? This just gets Wi-Fi because yes, of course you need Wi-Fi. So I don't care about that. Well, it says AC, so that's Wi-Fi AC, not Wi-Fi AX, which AX is Wi-Fi 6. Then we have the B550M Pro4, which does this literally have more USB ports than the regular? It does. Yep, that's 2, 4, 6, 7, 5. Yeah, I'm not blind. This actually just has more USB ports. I'm assuming because there's less internal headers, right? Because this has a USB 3 there and a USB 3 there. And this has a USB 3. And no, this also has 2 internal USB 3 headers. ASRock? Why? Wait a minute. Oh man, no, we need to go to this one. They even have the blank for the extra USB ports right there. Why didn't they populate them? Like, yeah, see, there's a hole for the extra USB ports. And it's like they put them on the MATX board, but not on the ATX. Why? I'm very confused. Like the M-ATX is literally a better motherboard than the ATX. Actually, in more ways than one. Um, this has two M.2 slots. Does this have three or something? No, this also only has two M.2 slots. So yeah, literally this is a better board than the ATX board as far as I'm concerned. Like you've got more USB ports in the rear I/O, you've got the same number of 3.0 ports internally. You have the same number of useful PCIe slots because like this is a what? So you have your X16, X1, X16 and well that's an X4 but X16 length and then you have an X1, right? Like I don't think you're going to be well, I don't know how many like some people might actually have four PCIe slot like four PCI cards that they want to plug in, but most people don't. So in that scenario, it's like this is just straight up better. And in fact, you could run Crossfire on this with two GPUs. I wouldn't recommend doing that, but Crossfire will actually run through a chipset badly, but it will run. Um, so you could actually run that on this and still have like, you know, if you had actually you could probably do quad crossfire. If you had like like a 7990 and another 7990, you could put one on the chipset, one on the in the top, and you could still fit a sound card in between the two. Or like whatever 1X card you want in between them. They even have a little Wi-Fi like slot for M.2 thing right there. So yeah, I have no idea why you'd buy the ATX version because the MATX version just looks better in every way. I'm gonna wait, are they gonna charge extra for the MATX version? Because there's a chance that the MATX ends up being slightly. No, like ITX is this awkward form factor because the boards are so small they end up costing extra, but MATX doesn't necessarily have to be affected by that. So this could actually end up being slightly cheaper than the Pro 4 or the same price and just better in every way because you get the same VRM heatsink, I assume same memory topology, um, and then like a better rear I/O. So yeah, I'm kind of confused by that, but this actually doesn't look terrible or completely terrible either. Like again, like I wouldn't necessarily want to run a 6 core on this. I mean 16 core on this, but if you're running a 6 core or an 8 core, yeah, that should be fine. Um, yeah, so obviously not on power stages. Probably the same four-layer PCB as the Pro 4, which makes sense. Um, yeah, not really. Like, there's not much I care about in there. And I'm assuming this has Realtek networking, 1 gig. Yeah, Realtek 1 gig. So yeah, this like depending on how this is priced relative to some of the other MATX boards, this doesn't look like a terrible option. Depending also like I'm gonna guess this should be sub $100, right? Like I'm surprised they don't have like a B550M Phantom Gaming 4. Oh, they have the B550M HDV. This better be like a $60 board. Like this better be a $60 board. Oh my god, this is awful. It's got a literal four, like it literally just has a 4-pin. Technically, you could still run a 16 core at stock off of that one 4-pin. Um, yeah, this has to be like $60-$70. Like, there's no way. This is two DIMM slots. Like, they are every corner that could be cut is cut with this motherboard. You've got two DIMM slots. It's not even a full MATX PCB. You've got a PCIe X16 and a 1X. You've got like one M.2 slot, the dinky like a like a cheapo chipset heatsink, which actually I prefer this stuff. Like this probably is a better chipset heatsink than what you get on the other boards in terms of surface area, because it has actual fins on it. How's the rear I/O? Pretty terrible, but like yeah, this. And then, of course, the VRM has no heat sinks. You can already, like, they've even shaved off one of the bulk input filtering capacitors because that was apparently too expensive. And is that literally just a high side and a low side MOSFET per phase? Oh, there's also, like, no output filtering either. Oh, man, yeah, this is really, like, this is for, like, office PCs. Um, Yeah, so this is like, man, this is gonna like, I I would not. Is there a support list for CPUs? Oh no, there isn't. No manual either. I was kind of hoping they would list like CPU support because I would not put a 3950X anywhere near this. Like, yeah, like no, I would not put a 3950X anywhere near this. Because the thing is, the 3950X has a 144 watt power limit. Like there's no way that VRM is doing 140 watts. Absolutely no way. I wonder if this can overclock. Voltage multi-adjustment. Oh yeah, that's exactly what you need on this mother. Well, I guess if you want to undervolt your 3950X after the hopefully this has working over temperature protection. But yeah, after your motherboard shuts down from overheating, you really need that voltage adjustment so that you can undervolt your 3950X into making this run at stock. Because otherwise, yeah, this is not gonna this is not gonna work otherwise. But yeah, so overall, ASRock's B550 lineup, there's not a lot of variety, mostly because they have like three of the same board right here in the Steel Legend, the Extreme 4, and the Phantom Gaming Velocita. The ITX options look interesting, especially this one. Like, if you, like, I know I'm like, the heatsink is very much a joke, but hey, if this is significantly cheaper than all of the other B550 ITX boards, I would not have a problem buying this and then gluing on extra heat sinks onto the existing heatsink to get this to run cooler. Actually, depending on how what kind of, how much space you have between the VRM and your, like, whatever you're cooling the CPU with, you might even be able to cram heatsinks onto the inductors, and depending how much space you have behind the board, you might be able to glue heatsinks onto the back of the board. That works, actually. Like that is a good idea. That works just fine. So you could actually, like, basically, if you were committed to improving the VRM cooling on this board yourself, this could potentially be a very interesting option. Um, I kind of wish they had shipped this board with a backplate, honestly. Now that I've thought about the whole, like, but and then it would have cost more. And I'm not sure how much motherboard backplates cost, but like how much the motherboard backplates affect retail pricing. But yeah, if you're willing to glue on your own heat sinks, this could actually be pretty decent because we actually have a 6 phase of 50 amp power stages. That's not that weak. It's just that there's no cooling for it. um, so yeah, this is an interesting board. This is also actually, like, depending on how this is priced, this isn't that bad. This is bad. We've already seen that. This also, like, I don't think this is going to be the best. Wait, not wait. Ah, opened the same one twice. I'm an idiot. Um, anyway, like this, I don't think is necessarily going to be the strongest B550 option, but like, yeah, I don't think this is going to be the strongest B550 ITX motherboard option. So if you were like, but at the same time, I don't think it's completely terrible. So this could actually be like, it really depends on pricing. Like if this is like, like my guess right now is going to be, this is going to be one of the cheapest ITXs, if not the cheapest B550 ITX. This is probably going to be the second. Then above that, we're going to see like Gigabyte. Then above that, MSI and Asus. I'm pretty sure MSI and Asus ITX options are going to be the most expensive, just because Asus ITX options are generally the most expensive. I can't think of a chipset where Asus didn't have the most expensive ITX motherboard. Um, Not necessarily the best. I'm just saying most expensive, okay? There's a big difference between the two. Um, but yeah, and then I guess the board to watch out for, in my opinion, is the B550 Steel Legend, because like freaking postcode, and they've axed a bunch of the sort of like unnecessary extras. Like if you have your motherboard in the case, the postcode is still very useful. It's like, but the power, like the buttons aren't, right? Because it's in a case. You don't need the buttons. Um, and so in that scenario, this is a really interesting board because of, because of the postcode, and yeah, you get a solid VRM on this, and then also the B550 MATX Steel Legend also is a pretty interesting board. Like, this doesn't look completely terrible either, and yeah, actually has a pretty decent rear. Actually, all of these have yeah, these are all very similar in terms. Wait a minute, this has more USB 3 ports. Why am I blind? Yeah, it does have more USB 3 ports. Why? ASRock's USB port assignment seems to be just completely random. Also, this has a clear CMOS button. Like, that is really weird. Does this not, like... And you have two internal USB 3 headers again. Oh, this has the 3.1 or 3.2 header. Man, I hate USB port naming schemes. I give up. But yeah, so ASRock's B550 options look interesting. The Taichi looks like it might be too expensive to make any sense. But something like the Steel Legend, this could actually be a pretty good alternative to, like, cheap X570s. Though I think they should have made it, like... This looks like it might be a bit too expensive, but I'm not sure. Like, if it's under $200, this is a really cool board. If it's over $200, it's kind of like, X570 is, like, basically the same price. And similar goes for this board. If it's under $200, cool board. If it's over $200, not cool. Actually, yeah, well... Actually, no. Even if this was over $200, there's, like, no good X570. There's not really any X570 MATX boards. So, actually, this doesn't have any competition for that. So, it would actually be fine. Man, I wonder if we're going to see, like, some really ridiculous... Actually, no, we're not. Because MATX, like, well, not so fun fact. MATX is the neglected form factor. Motherboards just don't care about it. Also, this, yeah, does have the post status checker. So this is a cool board. So yeah, ASRock has some pretty interesting B550s. Like, compared to their Z490, I think I said as much in my Z490 video, about ASRock's Z490 lineup is, like, I guess ASRock really doesn't want to sell any Z490s, but but they do want to sell B550s, because I like a lot of what I'm seeing here. Right? Like, and it makes sense. Like, B550 is probably going to be the significantly more popular chipset. Just because, like, it's Ryzen, and Intel doesn't really have a good low-end option for CPUs. Like, you're not going to buy a 10400. That's stupid. So, yeah, like, B550s for 3600s. Like, the thing is, pairing a 3600 with this thing might still be kind of unreasonable, but at the same, like, 3700X on this would be cool. 3900X on this would still be cool. 3950X would actually, yeah, still be cool. Like, the thing is like, if like, with Ryzen, most of the time, you're not actually going to be overclocking, At most, you're probably going to be, like, tweaking your power limits a bit to get a little bit of multi-core, extra multi-core performance, because Ryzen doesn't bloody overclock, mostly because of what AMD's done to the boost system. Like, on 2nd gen, you could actually kind of, trick the boost system into giving you more performance. With 3rd gen, you try to do that, and most of the time, you just get results that don't make any sense, where, like, some benchmarks go up slightly, a bunch of other benchmarks go down slightly, and overall it's a huge waste of time and frustrating and pointless. So overclocking 3rd gen is not fun. And so if you're not gonna if you're gonna run, like, a 16-core stock with overclocked memory here, this makes perfect sense. Like, this is a cool board for doing exactly that, assuming that it's cheap enough. Because you have the postcode, which will, make your memory overclocking life maybe ever so slightly easier. And you do have the 2-phase memory power, which probably won't make any difference. But, yeah, so that's my thoughts on the entire... actually, I don't think this is... it looks like they're probably still going to have more awful motherboards like the HDV right there to release. Because so far, I feel like there's a bad MATX option missing. Like, this is a really bad MATX option, but I feel like the B550M Pro4 is a little bit too nice to be the... Like, there's no middle ground between this and this, and I feel like there should be. But then again, I have no idea how cheap this board is going to be. Like, if this is like it doesn't really make, like, how much sense does it make to have a, like, oops. Like, how much sense does it have to have like to have like a 90 and then an 80 and then a $70 board? Though this might be like a 60, and then it would make sense to have like a 90 and a 75 and then your 60. So yeah, I feel like there's still maybe some boards missing here, but this is probably the most complete lineup of B550 boards I've seen so far. So yeah, that's why I decided to do the ASRock ones first. Also because these actually don't suck. I'm surprised by that. These actually look like really solid. Like, some of these look like really solid options, and some of them just look interesting. Like, I might actually buy this and mess around with just gluing heat sinks onto the VRM until it stops overheating. Because definitely you can definitely get this to overheat. Like, there's no heat sink right there. But yeah, it also looks like they've given you just enough surface area on top of that heatsink to apply thermal tape. And if you can apply thermal tape, you can build a bigger heatsink yourself. So, yeah. Anyway, that is it for the video. So, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestion down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly. There's a link to that down in the description below. And other than that, if you'd like to support me, well, the other option for supporting the channel is you can go buy some merch on Teespring. There's shirts, there's stickers, there's posters, you know, the usual YouTuber stuff. So, yeah, and there's a link to that down in the description below as well. And, yeah, that's it for the video. So thank you for watching, and goodbye.